Hello guys and welcome back. In this video I wanted to show somewhat an advanced example on how to create an energy moving through a path. This could be a lightning, it could be a magic force traveling through from point A to point B, and we're going to learn how to create that. Now, when it comes to effects, as an effects artist, you're going to be dealing with three things as a type of as a data on how you can present effects. So we have effects that is particle based, we have effects that is volume based, and we have effects that is geometry based. Okay, now with the particle based, in Houdini, luckily there is nothing special about particle based animation. It's the same data that you work with when you use geometry. Everything in Houdini is treated as points. So whether you have a particle, a sphere emitting particles with turbulence affecting them to create some kind of interesting motion, the end result of the particle sim is point. You just get points from the sim. And in Houdini, point is a point, whether it's in a geometry or whether it's coming from the particle sim, and this is just points. There is nothing special to this. Now the cool thing is points can be created at the SOP level, and it can be created at using sims as well, and we're going to learn how to do that. Now with the SOPs, it's very easy, and you don't have to use sims. Okay, and this example that I'm going to show you does not use any sim. We're going to start with a curve, build a curve, and then add and convert that to points and give them interesting motion. Now the other type of effects that we can create is volume based, and this, for example, it could be a static volume like a cloud, for example, that does not require a sim. So we can create a cloud with this. It could be an atmospheric effect where you have, let's say, foliage or an exterior scene, and you wanted to create an atmosphere with noise in there. You can create atmospheric effect using this. And you can also create fluid smoke sims or pyro explosions and things like that. So smoke sim. These are all using the same type. And again, we can create them in SOPs, which does not require sims, or we can create this type of data using sims to generate smoke and things like that. Now the geometry based is a gray area. Well, not so much, but there's a variety of things we can create with geometry. Let's say, for example, you wanted to create an ash simulation or sparks. You would want to create an actual geometry where you can map a texture of an ash burning, or you have a sequence of an ash burning. You can map that. So that will be geometry. You can also copy, for example, a grid or a plane and deform that and add noise to it. And the geometry based could be a cloth sim or an RBD sim. And again, we can create a geometry in SOPs dynamically, or we can use the simulation to add motion to it, if, for example, it's a dynamic sim. And these are the three different types. We have points, volumes, and geo. And point is a point whether it's a particle sim or it's a sphere. It's all the same thing. And I'm going to create a geometry node and delete that and create 2 points. And I'm gonna show some things briefly, and hopefully next week I'm gonna explain everything in detail, but I want to show you guys this example. So I'm gonna create 2 points. This first one is at 0, 0. Okay, see it there? And we can change the size of the point by hitting D, going under geometry, and we can increase this point size here. So let's set it to 10 so it's easy to see. Okay, and then I'm going to copy this and move it here. I'm going to merge these two guys. Now they're both together. It looks like we have 2 points, and I want to connect them. I want to create a line in between. I'm going to create an add node again. This node name is very very unusual, but it does a lot of things. It doesn't just add geo, it deletes as well. So in this case, we want to connect these 2 points. So I'm going to go under polygons by group, and you can see the default is set to all points, and now we have the 2 points connected. I can select the first point and move it, and the second point as well. Cool. So if we view the points, you can see we have only 2 here, and I want to create some kind of force traveling through the path. So we want to add a lot of points in between to be able to work with them first, but right now we have just 2. And to do the to add the points, we're going to use a node called resample, and this takes in any geometry and tries to multiply the number of points in between each connection. So in this case, it's set by length to 0.1, and now we have 107 points. Cool. So I want to add some noise to this. So I'm going to create a point vob. And what a point vob is, it's basically a second level where we can access further data in Houdini and manipulate it. So these points, they have position. They have an attribute called position. Okay. If we double click on this node, it's going to take us inside. It's going to take us inside. We can access the points and modify them. So in this example, I'm going to generate a noise first. And if we connect this here, we can generate a noise per point. And I'm going to view this as a color. So I'm going to plug it into the color here. You can see we're getting this noise pattern. And right now it's set to 1D. So it means a float noise. It's not a 3D noise. Okay, I'm going to change it to 3D. You can see the color changing now to red, green, and blue. And what this noise allows us to do is we can modify the points using this data. So I'm going to use an add node and take the existing position and connect the noise to it, and then plug that back into P. You can see now we've changed the path. Okay, now we can change the frequency, we can increase the amount of noise, which is cool. But what I want to do is I want to be able to have this movement, have this noise travel along the curve. So let me move it like this. You can see every time we move it, it changes because the input changes and it affects the result of the noise. Cool. So what I want to do is I want to keep this, and I want to feel that it's moving across. Now with this noise, there is an offset where we can move it along a specific axis. Let's try the Z here. Okay, it's doing something, but it's not traveling. I'm not seeing it traveling. Let's try this. The Y, it's moving it along the Y axis, so it's not going to work. The X is good. So we can use this to move our animation, but it's working not because this is doing the right thing. This is just because the curve is pointing in this direction and it's working by coincidence in this example. If we had the curve doing, for example, something very, very different. Let's see this. Let's do a soft transform. So if we had the curve like this and do this, the movement is not gonna travel nicely through the curve. It's just traveling through this axis, and we want to make it work properly. What we need for that is we need a value that starts 0 here and increments and becomes 1 here. So we have basically a length or gradient along this curve. So I'm going to do that. I'm going to go back to the resample node here. I'm going to create a UV texture node. And what this does, it can take any curve and create a UV coordinate based on its length. So the UV coordinate of X will be 0 here and 1 here. So I'm going to change this to arc length spline. I'm going to set this type to point. I don't want it to be a vertex attribute. And now we have the UV. If we take that UV coordinate and view it, let's create a new point VOP. We should see a gradient. Let's go dive inside. This is our UV. We only need, it's a vector, so we only need to access the X. I'm going to use a node called vector to float that will allow us to access the component of this. See, now this is one float, and I want to see the X. Cool. So we have this linear value here. And what I'm going to do is, let's copy that. I'm going to go back to the noise here. And I'm going to paste that node, and I want to access the UVX. Okay, and here in the offset, I want to use that X information as an offset. So I wanted to connect it here. And to do that, we cannot connect a float to a vector like this. Okay, if we connect the UV directly, the offset is going to map to the X. And I want to pass in the z-axis. So we need to construct the vector again. So float to vector. And I'm going to use the z-axis into the, the x-axis. Come on. The x-axis into the z. I'm going to leave these two empty. I don't care about them. I'm going to connect this as the offset. And let's add a constant. We want to be able to offset this because right now it's being driven automatically and we don't have access to that. So I'm going to add an add node here. Okay. I'm going to middle click and say promote parameter. And what this will allow us to do is we're going to be able to drive it from the upper level. And if we slide this through, you can see it's working properly. Okay. It's still not 100% correct. And the reason for that is because we still don't have the noise. It's traveling along this axis because it's just aligned to that through that axis. And the way to make it work perfectly is we need to generate the noise using the X and Y coordinate first, and then the Z axis is going to be this guy. Okay, so let's do that. I'm going to split the position into 3 components. Okay, and I'm going to use the X. Let's do it again. So I'm going to use the Z from the UV X coordinate. I'm going to use the Y and X from the original input. And this is going to be my position information. Let's turn this off. And now we're using the offset. We don't have to do it. We don't have to use this linear value as well. We can use this now and it should work properly. So you can see it's moving. Sorry, no, we have to use this. Yeah. So the offset, and let's go back up. And now the noise is changing. Let's turn this off. Let's increase the amplitude. I want to make it clear. And let's change this value. And you can see it's moving now much better. Let's set this back to 2. Let's increase the frequency. Turn this off. You can see now the pattern is moving through the curve nicely. Cool. So we can use an expression, for example, called $F that will return the frame number in here. So $F will return the frame, but it's going too fast. You can see the jump is too big. I don't want that much of jump. I want to reduce that by 10. So it's a lot slower. Maybe by 100. Cool, and you can see it now, it's traveling much better. We don't have to use the offset. We don't have to use the offset here. We can just use the change the position with this offset, and that will take care of the rest. We don't have to do this, the offset, and this will follow along the curve nicely. We can go back here. Let's add a soft transform. Something like that. And you can see it traveling through. Now the noise is not that great. The pattern is not very visible. But yeah, it's moving through. Cool. So this is our curve, and we want to make this more interesting. So let me turn the soft transform here. Let me delete this. And I want to make this curve, I want to add more data to it. And the easiest way to do that is to copy this multiple times, copy this curve multiple times and deform each one of them a little bit differently. But it's tricky to do this. So what I'm going to do is I'm going to show you a different node that where we can take any geometry and copy it to these points. Okay, and I'm going to create a circle. I'm going to use a copy node, copy 2 points, and this takes in the geometry and then the points that you want to copy along, and it makes a copy. Let me scale it down. You can see now each point has a copy. Let's change this to so that the alignment is correct, so the Y and Z is working properly. But if we look closer at the curve, maybe you should resample it higher so we get more data. If we look closer, you see that the circles are not aligned properly. And what we need to do is we need to generate a vector called normal that tells that the circle can use to find its orientation. And we just need to compute something called tangent for this vector. And the easiest way to do that is using a polyframe node, and it has this tangent name, and this guy computes the tangent for us. Now it's storing the attribute under the name tangent u, and I don't want that. I want it to be named normal, because that's what the copy sop looks for. It looks for an attribute called normal. If we view this, you can see now we're getting the tangent attribute stored as an n, as a normal. Now the circle, if we look again, it's lining up properly, but now its orientation is not working, so we have to change this. And there we go. And we have a lot of circles. I'm going to change them to polygon, give them a lot of points. I'm going to change it to open, so I just get the curve. I don't need it to be closed. If we go back, we have a lot of points now. Let's scale this down. Cool. And everything still works now. Because of the proceduralism, the curve is going to behave nicely. The polyframe will recompute everything, and we don't need to sim anything. Now, what I want to do is, because the circle is the same, it has 12 points, more, it has 51 points. I want to generate a line that connects all these points correctly. So I want this point to connect with the next one, with the next one, with the next one, and create multiple lines circling this. So what I'm going to do is I'm going to create an add node. I'm going to connect it here and go under polygons by group. I'm going to say skip every endpoint, and we need to find the correct value for this. Now the correct value is going to be 51. Because that's how much point we have. Now we're connecting everything nicely. Now we can change this, and that will add some rotation to the curves. And this is not a geo, this is all curves. Now, apart from the normals, there's another attribute that we can create to change the scale of these copies when we copy them. I'm going to create a randomize attribute in this node, creates an attribute and can randomize it, and it's very, very handy. The attribute that the node looks for is called p-scale. Okay, and if I middle click, you can see we have p-scale now. If we right click and go spreadsheet, we can look at the values. Right now it's creating a vector. You see 0, 1, 2. I don't need a vector, I need a float. So I'm gonna drag this all the way to 1, and now we have a value that goes between 0 and 0.9 or 1. And I don't want that much of a change. I want the minimum value to be 0.7 or maybe 0.6, and the maximum value 1, which is the default. You can see the curves are changing, and this will affect the path as well. Cool. Okay, so the last thing I want to do is I want to delete these points, these curves. I want to just leave the points. So I'm gonna add a node, add an add node, and tick on delete geometry but keep points. And this is what we have. We have all those circles. And the reason we're just left with the circles because if we click, that's how much points we have. But I don't want that. I want to fill in these guys, the path in between. So I'm going to add a resample node, and I'm going to, right now it's downsampling the path, so I'm going to set it to something higher. See, now we're getting more points in between. I'm going to increase that to something even higher, 0.02. And now we're getting a lot of points in between. So let's look at the resample node. And the point size that we chose before is quite big now. But I'm going to leave that as it is, and I want to show you guys a different mode to display the points that works really well when you have a lot of data. And if we go to right click here, go and tick on pixel, it's going to display these guys as a pixel. What that means is it will be 1 pixel no matter what the distance is from the camera. And this is a great way to view points. So right now it's very, very uniform. And what I want to do is I want to add another point VOP. And I'm going to add some more noise to it. Let's create a noise. Let's connect the P, add it here. And you can see now it's changing drastically. I'm going to change this to a 3D noise because we want that to be 3D. I'm going to increase the frequency. I'm going to lower the magnitude. Let's increase it more. And right now I'd like to tweak this a few times, and I'd like to layer them. And I also want to expose this. I'm going to quickly shift through, use the Y offset, the Z offset to move the pattern a bit. Okay, so I'm going to expose this, and I'm going to go back up. Let's play with these values. Now they're all accessible outside, so we can play with them nicely. Okay. So what I want to do is I want to layer multiple noises. So I want to create this one at 0.1, and for the offset I want to transform it $f divided by 100, so it's not too fast. Cool. And I'm going to copy this and add another offset and increase the frequency and increase the magnitude as well. Cool. So it's working pretty well, and the speed feels very, very slow. I'm going to change it to 10 times faster. And it's working pretty well now. And how much we have points? We have 500,000 points in this effect, in this pass here. And this is something you can use to add, let's say, an energy traveling between 2 points. Anything could be a lightning effect, could be anything really. And this is how you would approach it using just vex. Now with just subs. With these points moving, what we can do is, I'm gonna increase this guy so it moves faster. Moves a lot faster. And I'm gonna reduce the number of points so it sims faster as well. Okay. Cool. So it's very, very fast. But I'm gonna leave that. So these points, they're not changing. The count is not, the count is changing. Yeah, the count is changing, and the reason for that is because this path is changing, and all these resamples are based on the length of the curve. So what we need to do is we need to first find where the data is static. So in this case, let's take a look here, 622. Okay, so it's this guy that is changing the data. I'm gonna turn it off. I'm gonna say maximum segments. And I'm gonna increase this until I get the number I need. Okay, so 175, 175, 175, and this way the points are always consistent. And the reason I wanted this is because right now we have points deforming, they're changing position, but we don't have any velocity information, and this data is very, very important for the render to work with. So we need to do that, we need to compute that. The easiest way to do this, especially with the static point count, each point has a number, and that number is static throughout its lifetime, at least in this case. We can use a trail node and change it to compute velocity. Okay, and now it's taking the previous frame and the current frame and the previous frame, and it's computing the difference and storing that as a velocity vector. And this is how it looks like. This is our velocity vector. And when we pass this to the render, it will be able to create some really cool motion blur streaks. Now, to get an idea of how this could look like, just the stretchiness, we can use this node in a different way to trail the geometry. This is going to be a little bit heavy, but I want to show you the idea. So I'm going to use this trail node. I'm going to say preserve original, and trail length, let's set it to 0.1. The increment, I'm going to set it to 10. 1. Okay, set the increment to 0.1. Okay, so now it made 10 copies. Let's lower this to 0.1. .01. And let me increase this cache. We should see copies of this. So it is making copies. I guess the path is moving too fast. So yeah, something like that. It's making a copy, so that would be the path. I'm sure we should be able to create a much cleaner path with this. But I guess the movement is very quick. So this is we've got the velocity vector. We could send this to Mantra to see how it looks like, but I want to use this information to create some cool shading in this quickly. So I'm going to create a point VOP and dive inside. Let's move back. And I'm going to compute something called length. for the velocity. So this will give us back a float based on that is based on the magnitude of the velocity. So if the object is moving too fast, this length computation will give us a value, a float value that is high. If the object is not moving or the point is not moving, it will be 0. So I'm going to compute the length of the velocity, which is accessible here. And let's plug this back into the color. And right now you see everything is white. And the reason for that is because this value is very high. Let's take a look at the spreadsheet. You can see it goes up to 6, 11 there. So we have 11.5. Let's pick a different frame. So yeah, 11 looks reasonable. And we cannot view something higher than 1 in the viewport because it will just turn white. So what we need to do is we need to do something called remapping. I'm going to talk about this a lot more in the upcoming weeks. But what we need to do is we need to fit the range between from the alt range to something that we can view in the viewport. So in this case, it was between, the input is between 0 and 11. And the output, I wanted to remap this to be between 0 and 1, so it's visible for me. Okay, let's connect that. And you can see now where it's white, it's going to be, where it's fast is going to be white, and where it's slow it's going to be black. Now we don't have to use this white and black. We can actually change. We can use this to drive a mixing between two different colors. So I'm going to create a mix node, connect the mix, and this, let me set it to 3D color. So I want to mix between, let's say, yellow when it's very fast, and darker and more saturated yellow when it's slow. So these are the two color. The interpolation value, this is the guy that's going to drive the difference. And if we take a look, let's change, give it more contrast so it's visible. I'm going to change the viewport background to dark and turn off the grid. And it's set to pixels. So let's see. I'm going to right click and do a flipbook of this. And we should get the curve moving and the points changing. And again, we can render this in very interesting ways later. We're not gonna focus on that. Yeah, the movement is very fast. We're not gonna focus about the rendering, but this is an effects pass. It does not require sim, but we've created the final particle sim, which just points. Now, obviously, it's very, very, very motion blurred, and I'm gonna show you guys a frame of that. So let's create a camera. Again, you don't have to render this, just want to show you guys how this could look like. And let's make sure we have geometry, motion blur. I'm gonna create a mantra node. I'm gonna increase this sampling. Again, you don't have to do any of this, I just want to show an image of how this could look like. What's happening? Should be quick. Let me delete the p-scale. I'm going to delete all the unnecessary attributes. We're going to leave the color. Oh, maybe I hit render to disk. No, I hit render to mplay. Yeah, it's working. So we may not, yeah, it's rendering super big, so let me scale the points down to 0.01. Let's hit render again and see how that looks. Cool. And forgot one more thing, which is we have to turn on motion blur in the render. So let's hit render again, and it's gonna look very, very motion blurred. Yep. So that's the movements of the curve. And this is something very, very important. I'm going to talk about this later. There's a huge amount of effects that we can create just using SOPs and points, and they don't need to be simmed or anything like that. And motion blur and the accounting for motion blur and how it could transform the point is very, 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 very important when doing these kind of effects. So we have to always keep that in mind. Cool. Hope you guys liked this video, and see you in the next one. Bye bye.